All right, on to example 4, the last one in section 6.5. So according to Crown ATM Network, the average ATM withdrawal is $67. Assume the standard deviation is $35. Do you think the variable ATM withdrawal or ATM withdrawal amount is normally distributed? So I did just a quick look up before I made this video. It says that the average maximum, or I guess not average, but the maximum varies depending on your bank or whatever. But the maximum ranges somewhere from $300 to $2,000 in a day. So we've got an average of $67 overall. So do we think that's normally distributed? I'm definitely going to say no, okay, because if the average is $67, then clearly most people are taking out smaller amounts of money and not those maximums of $300 up to perhaps $2,000. Okay, so I would say most people do not withdraw an amount close to the maximum. Okay, so I would say in this case that our distribution would be skewed to the right. Again, you'd have most people withdrawing amounts over here, and then you'd have, a handful of people with those bigger amounts. But it seems that those smaller amounts, this would maybe be, $300 plus down here. Most are in that smaller range, okay? All right, so for part B, if a random sample of 20 withdrawals is obtained, describe the sampling distribution of X bar. Well, we can't say anything about it. Oops, sorry, forgot to turn off the highlighter. So this we would say it is unknown because the distribution of ATM withdrawals is likely skewed right. And we do not have n greater than or equal to 30. We've got an n of 20. So we do not know anything about the distribution if we only have 20 in our groups of samples. Okay. All right, moving on to part C. This time, if we have a random sample of 40, describe the sampling distribution. Well, this one we can do, okay? Our mean would be normally distributed because, again, we have that 40 in there. Our mean will be 67. Our standard deviation will be the $35 divided by the square root of 40. Okay. For question D, what is the probability a random sample of 50 withdrawals has a mean between $70 and $75? So we're looking for the probability that X bar, the average, is between $70 and $75. So normal CDF, we've got an N big enough. Our min and max are lower and upper bounds of 70 and 75, our mean of 67, and our standard deviation of 35 over the square root of 50. Okay, whenever we type that in, and I'm going to double check because I'm finding a mistake in my notes. So normal CDF between 70 and 75, 67, 35 over root 50. All right, I'm getting 0.2192. 2192. Okay. For question E, what's the probability a sample of 70, so changing our sample size, a sample of 70 withdrawals has a mean between $70 and $75. So again, same thing, 70 to 75. Here, the only thing that's going to change is that standard deviation. Again, the ability to copy and paste what you had is super nice because all you really need to do is change one number 5 to a 7 to turn that 50 to a 70. We will find the probability to be 0.2087. Okay. And then last but not least, compare the answers to D and E and explain why these probabilities are different. So even though we're still finding an average amount between $70 and $75, why are those probabilities not the same? Well, this goes back to what we talked about, I believe it was back in example 1, okay, is as your sample size increases, so as sample size gets bigger or increases, the probability decreases. In other words, it will be easier to find an average group of 50, okay, or sorry, a group of 50 that has an average between $70 and $75 than to find a larger group with 70 people in it whose average is $70 to $75. That would be even easier than finding a group of 200 whose average withdrawal is $70 to $75, etc. Okay, so as your sample size gets bigger, your probability decreases. It's just more and more difficult to find an average that is that high as your group gets bigger and bigger and bigger. All right, that is the end of chapter 6. So please definitely work on the homework from this from this section, but then also spend some time just going back and kind of looking through the whole chapter so that you get an overall picture of what's happened throughout chapter 6, where we started discussing the normal distribution.